Okay, so one thing we didn't get to in acids and bases was really talking about the pH scale. You know that it goes 1 to 14, that these are acids and these are bases, and the middle is 7, that's neutral. But what some of you commented on the video, say you put all these numbers, 5, 6, 7, is when you make one step on the pH scale, that 3 is actually 10 times stronger acid than the 4. All right, and I'm going to try to explain why it's quick without boring you to death. But basically, pH stands for power of H. Okay, so remember we said acids are things that are really good at giving off H pluses. The stronger acid you are, the more you're good at giving off H pluses. So that's what pH is. It's like how much H plus do you give off? So the formula for it, which you'll never have to use, but it does explain why it's like times 10 kind of, is that how much H plus, your concentration of H plus equals 1 times 10 to the negative pH. So you can see where there's like exponents in it and times 10 to the, so it's not, so you can kind of see why it's like every step is like times 10. Maybe you can see it. Not, that's okay. But if you were to plug like this pH into this formula, pH of 1 gives you 0.1 H plus concentration. 2 gives you 0.01. 3, pH of 3 gives you 0.001. So you can see it's like going down by like a whole decimal place every time. So it's actually like a whole like times 10, a power of 10 we call it. So you don't need to do all this, but basically what I wanted you to know is every step on the pH scale is actually that one's 10 times stronger acid, 10 times stronger acid. Or if we went the other way, 10 times weaker, 10 times weaker. So every one is times 10. There's this other little thing you might see in college, and again, it uses that formula, but you really don't have to understand the formula. You basically have to know if they give you the H plus concentration like this, they say, well, the H plus concentration is 10 times 1 to 10 to the negative 1. That negative 1, remember how in the formula was like H plus concentration equals 1 times 10 to the negative pH? That little exponent is your pH, but negative. So take the negative off, that's your pH. If your H plus concentration is that little exponent, that's your pH. Just take away the negative sign. If your H plus concentration is this, your pH is that little exponent number. Your pH is 3. So just knowing that if you ever see it written that way, where the H plus concentration, the little exponent, that's your pH, right? Because that's the formula. So that's one thing you could see in college. So back to each step on the pH scale being 10 times stronger. So we could say a solution with a pH of 3 is how many times stronger than a pH of 4? Well, that's one step on the pH scale, so it is 10 times stronger. All right, what about 3 compared to a 5? Okay, well, that's 2 steps on the pH scale, so that's 10 times 10, which is not 20, 10 times stronger, and then 10 times that is 100. All right, so every step on the pH scale is times 10. So a solution with a pH of 3 is how much stronger than a pH of 6? Well, that's another step on the pH scale. So 3 is 1, 2, 3 steps on the pH scale stronger than 6. So that's 10 times 10 times 10 is 1,000 times stronger. So every jump on that pH scale means a lot. The other thing is just knowing, okay, so I can figure out 3 jumps on the pH scale, that's 1,000 times more acidic. Just which way you're going. So in this case, they said, is 3 1,000? Is it 3 1,000 times more acidic, or is it 1,000 times less acidic? Like, which way is it? So you have to remember, if 1 is like the strongest acid, the closer you are to that, the more acidic. So if you're talking about 3 and 6, you would say that 3 is 1,000 times more acidic than 6. If you were talking about, I don't know, 6 versus 3, you would say like if 6 could be 1,000 times less acidic than 3. So just remembering that the closer you are to 1, you're more acidic. Just one little thing to know here is that just remember that bases, they release OH negative. Acids, they release H plus. So if you have different solutions, bases, you should have more of the OH. If it's an acid, you should have more of the H plus. So, I mean, things might have both. You might have like this mixed solution, but if it has more H plus, it's an acid. If it has more of the base stuff, OH negative, it's a base. Other than that, we're going to skip this part. Okay, here's a better part where I explain it better. So just know that like you can have both acids and bases contain some H plus and some OH negative. And just remember that it's the bases that contain the OH negative and the acids that contain the H plus. So if something has more of the acid one than the base one, it's acidic. If something has more of the base one than the acid one, then it's a base. If they're even, if there's the same amount, that's when you're neutral. Ah, shoot. Okay, I think I just messed this up. But here's just a couple practice, and then we're done. What happens to the hydronium ion concentration? That's the acid one. As pH changes from 6 to 3. So I go, okay, 6, 5, 4, 3. That's 1, 2, 3 hops to the left. That's 10 times 10 times 10. Okay, that's a change of 1,000. Okay, so that's my answer, 1,000 times. But then I'm like, is that 1,000 times more acidic or less acidic? They said I went from 6 to 3. So that's this way. And they will sometimes flip it and go the other way. So that way is going towards the 1. That's going towards more acidic. So I'm going to say that my hydronium ion, my acid ion concentration increases by 1,000. I'm getting more acidic. I'm getting more of that acidic ion. Next one. What happens to the acid ion as pH changes from 1 to 2? So I'm like, okay, that's one step on the pH scale. That's just times 10. But is that 10 times more acidic or 10 times less acidic? So if I'm going 1 to 2, I'm going away from the acid side. So this is getting 10 times less acidic. So I should have less of that acid ion. So I'm going to say it decreases times 10. Okay, and final question. What is the pH of a substance with an original pH of 5 that has increased in hydronium ion concentration 100-fold when acid is added? So now they're not telling me what happens when you go from 5 to 7 or 5 to 3. They want me to figure it out. So I'm like, okay, 5, 100-fold, that's 10 times 10. So that sounds like 2 steps on the pH scale. So there's kind of 2 parts. How many steps on the pH scale is how many times 10s? And then am I getting more acidic or less acidic? So how many steps and in which direction? So I'm like, okay, that's 2 steps. 1, 2, or maybe 1, 2. I'm not sure which direction. So let's see. What is the pH of a substance with an original pH 5, so start at 5, increased in hydronium ion concentration? So that's like increasing my acid ion. So I'm like, oh, getting more of the acid ion. So I'm going this way. Okay, so I'm figuring out, am I getting more acidic or less acidic? So now I know it's 2 steps in the more acidic direction, which you might be like, oh, bigger number, but no, more acidic, 1 is the most acidic. So I'm going 2 steps in the more acidic direction to 3. So basically what to know for this unit is that every step on the pH scale is times 10. And oftentimes you have to figure out how many steps, each one's times 10, and then am I getting more acidic? So a few steps in the more acidic direction to a lower number, or less acidic or more basic steps in the other direction.